Hi folks, this is the second trigonometry proof. So we have to prove that cos of a minus b is equal to cos a cos b minus sine a sine b. So this is quite a long proof. It's the longest proof by far. So we already know from the first proof that cos squared theta plus sine squared theta is equal to 0, is equal to 1. And we know that any point on the unit circle, we can call it cos theta sine theta. So what I'm going to do here is I'm going to pick 2 points on the unit circle. So this is all you have to remember, how to remember all of this now. So I'm just going to pick this point here and pick this point here. And I'm going to call this point cos A sine A. And I'm going to call this point cos B sine. So we can call any point on the unit circle cos and sine. So the angle A then would be this angle here. So it would be all of that there. That's the angle A. So the angle, I'll just remove that for a second. And the angle B would be this angle in here. So it would be up to that line. So therefore in the middle has to be, you should be able to see it's going to be A minus B. So it's whatever A is, the whole thing minus the small angle. So what we're going to do is we're going to find the distance. I'm going to call the first point P and the second point Q, just so we have them called something. So I'm going to find the distance from P to Q. So really it's going to be the length of this here. It's from that, it's that length there that we're going to find, but we're going to find it 2 ways. So the first way, I'm just going to use the distance formula, so the x2 minus x1. So that's just distance formula for 2 points. So I'm going to find the distance between those 2 points first. So let's just concentrate on that for a minute. So it's going to be so that would be the distance from P to Q. So let's just square everything out then. So if you square out the double brackets, you're going to get cos squared B minus 2 cos A cos B plus cos squared A, then plus sine squared B minus 2 sine A sine B, and plus sine squared A. Now I'm just going to let the whole thing be equal to PQ squared, so you can see that around, and that will just remove the square root. And then I'm just going to rearrange it around a little bit, so I'm just rearranging the terms that are in there. So into cos squared A plus sine squared A plus cos B plus sine squared B minus 2 cos A cos B minus 2 sine A sine B. Now cos squared A plus sine squared A will be 1, that's from the first theorem, and cos squared B plus sine squared B will also be 1. So it doesn't matter what the B is, so that they have to be 1. So therefore we're going to get 1 plus 1 minus 2 cos A cos B minus 2 sine A sine B. And then I'm just going to get 1 plus 1 is 2. I'm just going to factorize out the 2. So 2 minus 2 times cos A cos B plus sine A sine B. I'm just factorizing out the minus 2. and that's all. So I'm just going to leave that there, and now I'm going to go back up and I'm going to do the same thing again, but I'm going to use a different method. So I'm going to find the distance from P to Q again, but now I'm going to use something called this cosine rule. So PQ squared, if you're to imagine that that is a triangle, isn't it? So if we're to use cosine rule, PQ squared, so that's the distance up there, that is equal to, now the distance from there to there has to be 1, and the distance from there to there has to be 1 as well, because they're both just radius of the unit circle. So it'll be 1 squared plus 1 squared, so that's the b and the c here in the cosine rule, minus 2 times 1 times 1 cos of the angle, and the angle in the middle then is the a minus b. So we get 2 minus 2 cos of a minus b is equal to PQ squared. And I'm just going to leave it. So now we know what PQ squared is there, and we also know what PQ squared is over here. So PQ squared, we're just going to let both of those things be equal then. So we found the distance between the points in 2 different ways. So I'm going to let so 2 minus 2 cos A cos B plus sine A sine B is equal to what we got up here. So 2 minus 2 cos A minus B. So if I bring across the 2 and subtract it, it'll cancel out anyway. I have a 2 on both sides, and the minus 2, that'll cancel out because it's just being multiplied on both sides as well. So we just end up getting that then. So cos A cos B plus sine A sine B is equal to cos of A minus B. And then that's it. That's the theorem that we were asked to prove at the start. So it's just written the opposite way around. So it's a long proof, but it's easy enough to get your head around. The main thing is to remember the points on the diagram, to remember that the middle is the a minus b, and then it's just using both the distance formula and the cosine rule to find the distance between them in 2 different ways. You're just simplifying down in here, and then at the end it comes together nicely. Everything just cancels out and you just get what you were asked to prove. So it's the longest proof, but a bit of practice and you should be able to get your head around it. So that's it.